Hey everybody, today we are continuing on with properties of rational exponents. So our goal today is that I can write expressions in both radical form and exponential form, and I can evaluate expressions with radical exponents, rational exponents, and radicals. Okay, so the first thing is that we need to understand that radical form and exponential form are related. Okay, if you have the nth root of a to the m, you can rewrite that as a to the m over n power. Alright, so that goes the other way too. So if I give you 3 to the 7/5 power, that's the same as the fifth root as 3 to the 7th. And I always remember that the root is on the bottom, kind of like a tree roots. A tree's roots are in the ground on the bottom. So rewrite the following expression in exponential form. So the power, well, the base is x, and the power kind of stays where it is, and I move my root to the bottom of the fraction. So this is the same as x to the 4/3. So we also have this root right here. There is no number, but we should know as mathematicians it's because it's a square root. Alright, so a square root with no number there because it's the most common. So x to the 5/2 power. Alright, now let's rewrite them in radical form. So again, 2/5. So this, the 4 stays where it's at, the fifth root of 4 squared. The 4 here is the fourth root, so 3 to the 1/4 power is the fourth root of 3 to the first power. Or we could just write the fourth root of 3, right? Because we know that to the first power doesn't change anything. Okay, so we're going to go ahead and move forward for the rest of the notes, and we're going to do a couple different things. So make sure that you have minimal distractions. You're listening to only this right now. And you're super focused on what we're doing and jotting down any questions that you have along the way. Okay, so we're going to evaluate and simplify the radicals or rational exponents. So you're either going to get a situation where it's in radical form or it's in rational exponent form. So whatever form it's in, we're going to keep it in that form to the best of our abilities. So this first one really is review, right? This is the square root of 108. So I need to reduce this. So 108 is 2 times 54. 54 is 9 times 6. 9 is 3 times 3. And 6 is 3 times 2. And then I can bring this 2 down as well. So I have a pair of 3's and a pair of 2's. And that 3 is left over. So that means I can take 1 3 out on the front times the 2 out on the front, and then I have a square root 3 left over. So that's the same as 6 root 3. Okay, so reducing radicals is something we have seen before. But now we're going to change it up and look at this fifth root. So the only difference now is that I am looking for groups of 5. So I still need to make a factor tree. I'm going to ignore the negative till the end. So 243, you might need to do some work in your calculator, but it's 3 times 81. 81 is 9 times 9, and 9 is 3 times 3. So I'm going to bring this one down here as well. And then again, I'm looking for groups of 5. So this was a negative 243, and you're allowed to have a negative if it's a fifth root. Okay, because it's odd that these really are all negative, because a negative times a negative is a positive, then you have another 2 are a positive, and then you have a negative. So that's how we get this to be negative. So here's my group of 5, which means I can bring that out front to just be negative 3. There's nothing left over, there's nothing I didn't circle, so the radical disappears. Okay, so when we have rational exponent form, we're going to leave it in rational exponent form, and we're looking into reducing the base, okay? So I first want to write this down. You must show work. All right, I want to see visually that you understand what we're doing. So the number 100 is 10 times 10. All right, that's a good way to rewrite 100. If we go any further, we don't get something super nice. So 10 squared is 100, right? And all I'm doing is rewriting 100 as an equivalent expression. Okay, equivalent means it's the same, just written differently. 10 squared, so that's 100. I still have to raise it to the 3/2 power. Okay, so I'm not changing the problem, I'm just rewriting it. So now, if you remember, we have power to a power. I multiply those, so that is 3. 2 times 3/2 is 3. And 10 to the third is 1,000. Okay, so let's move on to number 4. So first we're going to look at 343. All right, so 343 is 7 times 49, and 49 is 7 times 7. So I can rewrite that as 7 to the third. Okay, that's just the 343 I'm talking about. I still have to raise it to the negative 2/3 power. So my base is 7, and then I have to do power to a power. So 3 times negative 2/3 is negative 2. We should know at this point that negative exponents are not allowed, so I'm going to move it to the bottom. So it becomes 7 squared, which is 1 over 49. Okay, and I want to see all of those steps as we move forward. You do need to show all of your work. Okay, example 4. Now we're going to simplify with variables. So again, these are in radical form. So if they're in radical form, we're going to keep them in radical form. And we need to simplify. So this is a third root. So I'm going to start with 125. 125 is 5 times 25. And 25 is 5 times 5. So there's my group of 3 that gets to come out front. So for sure I have a regular old 5. Then I need to see if I get anything with my y's. So this is y to the 6th power. So you can look at this in a couple different ways. This is y times y times y 6 times. I'm looking for groups of 3. So I'm going to circle groups of 3. So that means for each group I get to bring 1 in the front. So that's y times y. There's nothing left over. There's nothing uncircled. So my final answer is just 5y squared. Alright, the more practice you do, the better this will get. I promise. Okay, so now I have the 4th root of x to the 4th, y to the 8th. So anytime you take the radical of a fraction, you can rewrite this as the 4th root of x to the 4th divided by the 4th root of y to the 8th. Okay, I can do those separately. So let's think about this for a second. This is x times x times x times x 4 times. And then I have 5, 6, 7, 8 y's. So I'm looking for groups of 4. So I have one group on top, which gives me 1x on top, right? I'm taking out from under the radical. Then I have 2 even groups of y's. So y times y is y squared. Again, there was nothing left over, so I have nothing left under my radical. Okay. So here we have the 5th root of 5, a to the 5th, b to the 9th, c to the 13th. So if I tried to make a factor tree with this 5, I wouldn't be able to do anything because it's 5 times 1. So that 5 is going to stay exactly where it is. So I have 5 A's, so that's one group. So I have an A in front. I'm going to leave some space and see what I have left. Okay, I'm going to go one thing at a time. So I had one solid group of 5 A's, so I have 1 in the front, and that 5 is going to stay. Now I'm going to move to the B's. Okay, so B's, I have 9 of them, and I'm just moving over here so I can write them all out. 4, 5, 6, 7, 8, 9. So I'm looking for groups of 5 because it's a 5th root, so I get to circle 5 of them. But I don't have another full group, so I have one full group, so that comes out front. But I did have those 4 left over, and since I can't take them out because I didn't have a solid group of 5, so I still have b to the 4th on the inside. Alright, so then we're going to look at C. Okay, you can write them all out, which I'll show you in a second, But you can also say, okay, how many times does 5 evenly go into 13? Well, you'd have 5, 10, 15. So once you get to 10, that's 2 full groups. And since I got evenly to 10, the difference between 10 and 13 is 3. So c to the third, right? I had 3 remainder. So you can do it that way, or you can write them out. I'm going to show you how to write them out right now. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I had 1 group, 2 group. That's how I knew it was c squared, and I had 3 left over, so c to the third. Okay, but you can also think about it. 5 goes into 13 evenly twice with a remainder of 3. Okay, so abc squared times the 5th root of 5b to the 4th, c to the third. Okay, here's the last one of this type. Sometimes we have 2 radicals, but that's okay. We're going to multiply them. So 12 times 4 is 48. X to the third times x to the fourth is x to the 7th. Y to the 5th times y is y to the 6th. Okay, once you multiply them, you can actually reduce the radical. And this is a square root, so we're going to look for pairs. So 48, well, I already know it's 4 times 12, but you might want to do some more math and find something else, whatever makes you happy. And 12 is 4 times 3, and 4 is 2 times 2. So I have 2 pairs of 2's. So that's a 2 times 2 is 4. And then I have a 3 left over. Okay, and I left space because I still have to worry about my x's and my y's. So I just did my numbers first. Again, I had 2 2's, which is 4. 2 times 2. Then I have x to the 7th. So how many times does 2 go into 7? Think about it. If you said 3, you are correct. 2 goes into 7 3 times with a remainder of 1. And then how many times does 2 go into 6? If you said 3, you are correct. Okay, so that is my final answer. 4x to the third, y to the third, 3x. And again, if you needed to write those out, you have 1, 2 groups of, we had 3 groups of 2 with 1 left over. That's why we had x to the third on the outside and 1 inside. Or you had 6 y's, where we had, I'm having trouble counting, 3 groups of 2, so that's why I had y to the third with nothing left under the radical. And if I redraw this to make it look nice, it would look just like that. Okay, the last set of problems are adding and subtracting. Okay, you can only add and subtract if you have like terms. So for example, if you had 2x plus 3x, you get 5x. Well, we're so used to seeing x, that could be anything. It could be like 5 star plus 6 star equals 11 star. So this is the same here. 5 square root y and 6 square root y is 11 square root y, because this is our like term, and they're the exact same, so I'm allowed to add them. Okay, it's a little bit different from what we were just doing. And then let's go to part B. So here I have my radicals. They're not the same, but I certainly can make them the same, or hopefully reduce them to be the same. So the cube root of 5 isn't going to change, but I do have x to the 5th here. X to the 5th has 1 group of 3, so I can bring an x out front. And then I had 2 left over, so I still have a 5x squared underneath my radical. Then I have 40, so I'm going to do this over here. 40 is 4 times 10. Then I have 2 times 2, and 5 times 2. So I have 1 group of 2, so I can bring that out front to join the x. And then I had a 5 left over, so cube root of 5, and I have an x squared inside. And I know I can't do that because there's less on the inside than what I need. Okay, so now if you look carefully, these are like terms, right? The cube root of 5x squared and the cube root of 5x squared. So let's look at what we have in the front. I have 3x minus 2x is 1x, and then I have the cube root of 5x squared, because those are like terms. Alright, you do not have to write the 1, but for the sake of it being notes, I wrote it down so you have it and you know what we did. Alright, so I hope you had fun. I hope you wrote down any questions that you have. along the way, so you're prepared to ask any that you have when we meet each other next. See ya!